Welcome to our channel. In this video, we are going to discuss about entropy. In our channel, we are providing handwritten notes for every topic that we have explained and which is in very easy format and also better to understand. If any one of you need to download handwritten notes in a PDF format for this topic, you just go and check out the description or else comment section where I have given link to download PDF of this topic notes. Now, let's move on to the topic. Entropy is denoted by S. Actually, entropy is defined mathematically by using Carnot cycle. So, from the Carnot cycle, we define entropy mathematically. But right now, I am going to define this entropy from its physical significance. Entropy gives the measure of degree of randomness present in the system. So, why the entropy is used for? To measure the degree of randomness present in the system. That means more random the system is, more is going to be its entropy, and less random the system is, less is going to be its entropy. So basically, entropy is a factor by means of which we can measure the degree of randomness or the degree of disorderness of the system. If randomness or disorderness is more, then its entropy is going to be more. For example, if I have got solid, liquid and gas under same conditions, if I'll ask you in solid, liquid or gas, where will be the disorderness in the molecules maximum? What you are going to be answer? The disorderness is going to be maximum in gas, because in solid we have ordered arrangement, as you all must be knowing, and in the gas the molecules of the gas is going to be disordered. So disorderness of the gas is going to be maximum, followed by liquid, followed by solid. So entropy of solid is less than entropy of liquid, and entropy of liquid is less than entropy of gas when all these three present under the same conditions. Now let's talk about solids. On the basis of arrangement of constituent particles, we classified solids into two types. First one is crystalline solids and second one is amorphous solids. In crystalline solids, we have got regular arrangement of constituent particles. That means we have got ordered arrangement of constituent particles. Whereas in amorphous solids, we have got irregular arrangement of constituent particles. That means we have got disordered arrangement of constituent particles in amorphous solids. Now I can simply say that more the disorderness, more will be the randomness. More the randomness means more will be the entropy. So I can generalize the simple statement right here. Entropy of the amorphous solids is definitely going to be more than that of crystalline solids. Why? Because in case of amorphous solids, we have got irregular arrangement, that is disordered arrangement of constituent particles. So disorderness is more means its entropy is going to be more. So entropy of amorphous solids is definitely going to be more than that of crystalline solids. Look at this statement. As the number of atoms in a molecule increases, the structure of the molecule becomes complex. That means more complex is the structure, more is going to be disorderness. And more disorderness, that means more is going to be entropy. Let's say if I'll be having a process during which entropy of the system increases. I'm repeating. Let's say I'll be having a process during which entropy of the system increases. If entropy of the system increases with time, I will write the value of delta S. Here delta S means change in the entropy. So as the entropy of the system increases with time, S final is going to be greater than S initial. So delta S is positive for a process whose entropy is increases with time. Similarly, if I will be having one more process during which entropy of the system decreases with time, for that I would say delta S value will come as a negative. So remember that if for any process the delta S value is coming out as a positive, then that means entropy of the system is increases. Whereas if delta S value is going to be negative, that means the entropy of the system decreases. Let us try to answer some questions based on this topic. See, first question. In each pair, which molecule has maximum entropy? Over here, I have got NO2 molecule. At the same time, I have got N2O4 molecule. So now I have to check among these two molecules which one is going to have more entropy. Already I gave you one statement, that is, more atoms present in a molecule, more complex is the structure will be, right? So more complex is the structure, more is going to be its entropy. So I would say entropy of N2O4 is greater than that of entropy of NO2, because in one molecule of NO2 we have got three atoms. What are they? One nitrogen atom, two oxygen atoms, right? Whereas in one molecule of N2O4 totally we have got 6 atoms, 2 nitrogen atoms and 4 oxygen atoms. More atoms present in a molecule, more complex the structure will be. More complex is the structure, more is going to be its entropy. And the next one that we have SO2 and SO3. In case of SO3, the number of atoms are more. If the number of atoms are more, I would say that the entropy of SO3 is going to be greater than that of SO2. And the last one, CH4 and C2H6. So one molecule of CH4 contains 5 atoms, whereas one molecule of C2H6 contains 8 atoms. So which one has more atoms? C2H6 has more atoms. So more the atoms present in a molecule, more complex the structure will be, and more complex is the structure, more is going to be its entropy. So entropy of C2H6 is greater than that of entropy of CH4.